The next parent function on our list is the absolute value function, f of x, or that's just a fancy name for y, is the absolute value of x. So here, the table of values that I gave you, I've already completed. Didn't really have any reason for not just doing what I usually do, plug in a couple of negatives, 0, and a couple of positives. And when we do that, we see that we get a V shape here. It doesn't curve at all, but there's a sudden change in the direction right here. The origin, again, we would call a vertex. So that's the origin is the turning point on our parabola. We call that a vertex there. It's a sharp corner here on this graph, and it's still called the vertex. You'll notice these are two straight lines because it doesn't curve. I can, if I want to, actually write the absolute value function in what we call piecewise notation. Here, this side, this is just a line of slope 1, because that's just the identity function. That's just f of x equals x. If x is bigger than or equal to 0, the absolute value just gives us x. So it's going to be x if x is greater than or equal to 0. So this is just the right half of the identity function. Here, this line is just a line of slope -1. And the equation for that would be f of x, or y, equals the opposite of x. And that's if x is less than 0. So this is a very useful way that I can write the absolute value function by saying, okay, it's one rule, take the absolute value, but that one rule really has two parts. If I'm taking the absolute value of something that isn't negative, I just use the identity function. If I'm taking the absolute value of something that is negative, I'm going to take the opposite of x. Now, often students don't like to see this because they say, wait a minute, absolute value isn't negative, so how come there's a negative there? Well, notice the way I read that. I read that as the opposite of x. And I only use that rule if x is a negative number. Well, what's the opposite of a negative number? A positive number. So the result will be positive. You need to be really careful with variables, because with numbers, I can tell whether a number is positive or negative by whether there's a negative sign in front of it. But with variables, right here, just the symbol x is representing a negative number. So the symbol with the negative sign is actually representing a positive number. All right, so that's our absolute value function. The last one on our list is the reciprocal function, f of x equals 1 over x. And that's one that I'm guessing some of you are less familiar with than maybe some of these others. I'm sure your familiarity varies from student to student, but this one I want to just work through with you. So I did give you a table of values, but again, I'm going to just sort of think through strategically how I would choose the values that I would plug in. So I might say, okay, let's start with a couple of positives, a couple of negatives, and 0. So I might try -2, -1, 0, 1, and 2. And right off the bat, I might notice I have a problem right there, because I can't plug in 0 for x. So I'm just going to make a note. This is not in the domain. So when I go to graph this, there's not going to be any y-intercept. We can't touch the x-axis, or sorry, we can't touch the y-axis at all. Now, I can go ahead and calculate these other points. So the reciprocal of -2 would just be -1/2, and the reciprocal of -1 is -1. So when I take the reciprocal of a negative number, it's still going to be negative. So there-ish and there-ish. So there's my -2, -1/2, and -1, -1. Okay. And then the reciprocal of 1 is 1, and the reciprocal of 2 is 1/2. So there are my points 1, 1, and 1, 1/2. Now it's kind of interesting though, because I can see that I'm not going to be able to connect the points that I have over here in quadrant 3 to the points that I have over here in quadrant 1. Because if I wanted to connect them, I'd have to cross the y-axis, and we've already stated that we can't do that because 0 is not in the domain. So this y-axis serves as a barrier. It separates the graph into two pieces. There's the left side of the graph, and there's the right side of the graph. And now for each of those pieces, I have these 2 points. I can sort of see, if I were to continue going further away from the y-axis, if I were to go to 3, I'd get 1/3, 4, I'd get 1/4. So it looks like these values are going to be getting smaller and smaller and smaller, but they're never going to actually hit 0. Because even if my x value is 20 million, its reciprocal is still positive. It's 1/20,000,000th. Now that's going to be very, very close to the x-axis, but I'm never going to actually hit 0. Remember, a fraction is 0 if the top is 0 and the bottom isn't. But the top of this fraction is never going to be 0 because it's always 1. So what's going to happen as I move to the right is this function's going to get smaller and smaller and smaller, but it's never quite going to hit 0. So the x-axis here is a horizontal asymptote. It's a line that we're going to get arbitrarily close to as x goes off towards infinity. Now, up until this point, I haven't bothered plugging in fractions to any of my functions for table of values because I was employing what I like to call strategic laziness. I was trying to pick numbers that it was convenient and simple to plug in. But I'd kind of like to see what happens between 0, where I know I don't have a point, and 1. So I'm going to go ahead and add to my table of values. I'm going to plug in 1/2. Now the reciprocal of 1/2 is 2. So reading this backwards as I go to the left, now of course we read graphs left to right, so I'm trying to very clearly articulate that I'm reading it backwards now, going right to left. As I make x smaller, when I get to 1/3, we'll be up at 3. When I get to 1/100th, we'll be at 100. So as we get closer and closer and closer to 0, the y values are going to be getting bigger and bigger and bigger. But we never actually touch the y-axis here. So the y-axis is a vertical asymptote. So we get arbitrarily close to that vertical line, but we never actually are going to cross that. We can never ever cross a vertical asymptote. We'll see that the rules are a little bit different for horizontal asymptotes. This horizontal asymptote we never actually cross. There are functions that have horizontal asymptotes that do cross those asymptotes. You can never ever cross a vertical asymptote, however. All right, now let's take a look at what we have over here. I might want to do something similar. I can say as I keep going towards negative infinity, like if I go to -3, I'd get -1/3. So it looks like I've got a similar pattern here, that as I trace this backwards going to the left, my y values are getting closer and closer and closer to 0. They're negative, but they're getting less negative. And then if I were to plug in -1/2, that reciprocal would be -2. So I'm noticing that I'm really getting a mirror image of what's happening here. The closer I get to 0, the more negative my y values are getting. They're still negative, but their absolute value is getting bigger. So the reciprocal function looks like this. It's in quadrants 1 and 3, and both of my axes are asymptotes. So as x gets bigger and bigger and bigger, my y value gets closer and closer and closer to 0. And as my x value gets closer and closer to 0, my y value gets bigger and bigger and bigger. On one side, it gets bigger in the positive direction, and on the other side, it gets bigger in the negative direction. All right, so there's our reciprocal function, and that covers all of the parent functions. Now in 1.6, as I said, what we're going to be doing is basically manipulating the formula for these functions algebraically and seeing what effect that has on the graph. And that's going to be a lot easier to do if we're familiar with these functions. So if you were familiar with these functions already, fantastic. If not, once a day, pull out this worksheet and just run through it again. You may find that you want to plot the points all over again. You may find that just sort of looking at it and reminding yourself, oh yes, that was the pattern I saw, is sufficient. But you want to make these things that you feel comfortable with, it. These graphs are sort of at your fingertips. So somebody gives you this function, you're like, I know what that looks like. And you don't have to create a table of values because you understand the pattern that we noticed once we did create that table of values.